Konnichiwa friends, my name is Ashma Samasi and welcome to part 2 of the music audio multi class classification bootcamp. Okay, so in our second part of the video we are going to learn how we load the audio dataset using custom loader, what is data loader and how we use our GPU inside our system. Okay, in our very next video we are going to learn to make basic model, how to attach 1 dB and how to train a basic model here. Okay, so let's start. So first thing is that how could we load audio for our training. Okay, so in our last video you learned how you basically load the audio file using librosa. Now in our very last video on how you import the librosa here, then install and then load the audio file and then extract the mail spectrogram and also normalize the audio feature here. Okay, so this thing you must learn from the last video. Now the question is how could we load the entire folders for our training with our x and y. Okay, so this is the whole path here. Okay, so first we will load all files, then we will making to dataset, then making it to data loader, and then we'll be passing it to model. Okay, so here the data loader is the main part here. So this is the tensor dataset which the model will learn. Okay, so this is basically what an deep learning model actually learns. Okay, data loader, it is the package which basically gives the data and labels together in pytorch as tensors here. Okay, so in short, in machine learning you use x equals to data where you drop the label column and y where you put the label and then feed the model in x and y. In deep learning is same, you use data loader and here pass the data set with batch size and shuffle here. Okay, and this data loader will be the one your model will be training on. Okay, not like in our machine learning x and y. So how do we do that? So we do that using by first passing the data set. Okay, it will contain the audio and label together. So here you will see the files here and the labels here. Okay, we will have musics and the label one at a time. Then we pass the batch size and shuffle equals to true. So here shuffle basically shuffles the data. For batch size it basically divide our data into chunks. Okay, so basically with batch size equals to 2 we are basically dividing the whole data into two chunks which will be training on. Okay, so the whole data is divided into two chunks. If the batch size was 4, we will be dividing the entire data into 4 chunks here. Okay, if there are 16 rows here and the batch size is 2, then each batch have 8 data here. Okay, so 8 plus 8 equals to 16 like that. Okay, for 16 rows 2 batch, and if you have 100 rows and 32 batch, then each will have 3 data here except the last one where it will have 7 data points here. Okay, so we will be having 333 data for the 32 batches and the last 32 batch have these 7 data points. Okay, so now why we are having batches? So the answer is that deep learning works on very big data sets. Okay, audio files, music files, etc. are very big data set. So we don't fully feed the full data. Okay, instead we divide the data and train data by chunks here. Okay, and this is what the batch size actually defines. Okay, so basically we will be training on first chunk, then the second chunk, then third, fourth, etc. Okay, by this, and it will be defined by batch size of the data loader. Okay, so here the data loader path is completely understandable. Now the next is that how we load files for our training. Okay, so we basically have three types of structure. Okay, for our audio classification tasks. First is that we have an parent folder here and each child folder have the music files here. Okay, so we will be having car folder, then inside it we having car 1, car 2, and here each folder name of the child class is equals to the label part. So here we have car, then truck, and the car have the car sounds 1, 2, 3, etc. till the very last, and this is the structure one. Now the second type of structure is that we have a parent folder named dataset, and inside we have a child folder with the audio files and then labels.csv files which contains the file name and the file part, and the label here. Okay, now the third type of structure is the dataset, where basically the child folder have itself a child folder, and here the child folder signifies the index here. Okay, the first index will have n set of audio files, and then the second index we will have the same set of audio files here. Okay, and here basically the solution to this dataset is basically we will be merging the whole indexed files here. Okay, index audio files into the one audio file here. Okay, so here the car 01 index, we have horn and escalator, we join it there to form the audio. Now for how we will be doing this structure one custom data loader. Okay, before that we must understand how basically we make an custom Python data loader class in an Python file. Okay, to load our audio here. So as we know, for CSV file it is very easy to load it. Okay, but for our audio files, our picture files, or our Parquet files, it doesn't support natively. Okay, so for that we make a custom data loader class to load our files here. Okay, based on the structure here. Okay, so the class basically have three main functions. Okay, for our custom Python loader, first is the constructor class, which basically is used to list all files. Then we have our def len, which basically returns the length of the file, and then finally the get item, which returns the file as dataset here. Okay, it always return data as tensors and the label here. Okay, both part, the def get item. Okay, now also some important points is that os.list dir. Okay, it, so basically this function list all folders under the root directory. Okay, so if you will write here os.list dir and pass the path here, you will see all the folders and files it list. Okay, under that specific path here. Okay, so if you will pasting the parent folder here, you will see the whole folders here. Okay, so mainly print the folders, but if there is no folder there, it will start printing the files here. Okay, so this list dir basically prints the folders here. Okay, then we have our os.path.join here. Okay, so basically it joins the folder directory of root directory and the generic here. Okay, so basically if you will be passing the path of two dataset folder here, you will basically see the folder is join here. Okay, so the os.path.join basically join the two folder paths here. Okay, and it basically gives the whole link here. So now let's come to how exactly we'll be making the data set here. Okay, to get the audio files and making it to dataset, then the data loader here. Okay, so you will see here that my structure belong to the structure one dataset. Okay, so I'll be using the first structure here. Okay, finally, so we create a class name with audio dataset, which will take the dataset here, and then we make the init function, which will take self the root directory and the sample rate, which will be equal to 2050. Okay, then I will be creating the three local variable files, the labels and the sr variables. Okay, so we write here self.files equals to bracket, then we write self.sr, which is equals to sr, and our self.labels, which should be also empty here. Okay, here this self.sample rate will be equals to sample rate, which we get in the init folder. Okay, now we enumerate through our os.list dir. Okay, for our root directory, so it will list all the folders inside our list directory. Okay, so we write here labels and folders in our enumerate, and then os.list id of our root directory, which we will be receiving here. Okay, then also here the dataset will be coming from utils.data import dataset here. Okay, this dataset, then in our next we will be joining our root and our the directory here. Okay, so we will write here final path equals to os dot path dot join our root directory and our folder here. Okay, then we will be enumerating through the files inside the folders of this song genre here. Okay, so we write here os dot list id here for folder path, and then we'll be appending the audio paths here, and then we'll be appending the labels here. Okay, so we first appending the audio path, and then we are appending the label here. Also your label will be for the int type. Okay, so for our blues etc it will be appending 01 etc. Okay, so here we will append the path of the folder path and the files here, and then we will be appending the labels here. Okay, so by this we'll be doing the init function. Okay, then we'll be making new function called length which will be returning self dot files length here. Okay, this one will be writing is self, and then we'll be doing here dev dot get item. Here it will be taking self and index here, and here we'll be using our librosa here. Okay, the load file. So here we will be doing audio and sample rate equals to librosa dot load, and here we'll be reading the self dot files which will be depend on the index here. Okay, and here sample rate will be equal to sample rate which we pass here. Okay, so we write here self dot files, then inside it we paste the index here, and then for our sample rate we will use our sample rate which we initialize in our constructor here. Okay, then finally just a second, here our init and the get item, and then here will be in our get item we will be returning the toss dot answer and the cell dot labels here. Okay, so we'll be returning our toss dot answer, and here we'll be returning the audio and our cell dot labels here. Okay, depending on index, and this will basically create the whole folder here. Okay, so if you are creating a new variable here which will be loading our audio dataset here. Okay, and we are printing the first value here, and we'll see it is saying that we forget to import our torch, so it's okay, we import directly torch, and you could see here the values here. Okay, so we finally are successful to get the audio files in our dataset. Okay, and this is the audio numpy array which we got here. Okay, so you could go to 100 to 302, which will basically, since the labels here goes from 0 to 10 here. Okay, so we have done our audio dataset path here. Okay, also for our structure too, it is basically the same thing. Here we read this CSV with our labels dot audio, and for here we go from 0 to our length of the rows here which basically contains the file path, and then we join the file paths here, and then we load our audio sr and append and label the same way as we done here. Okay, inside our init folder it's practically the same way. Now for the structure tree, also for the code you could check my GitHub repository. Okay, you would only change the get items here. Okay, so here get items we directly load. Here we will be basically merging the stems of the audio files we have under the each child folder here. Okay, so if you are going to genre stems, we will have here each dataset here. You will see that the length and init path each same here, just the get item here will basically identifying it, then making audio sum, then we reading the file and we loading the file, then we merging the audio files into a single audio file here. Okay, so finally we are getting in one single audio file, then we are padding to make sure it is of same length, and we are returning the exact same thing. Okay, the toss.tensor and the label here. Okay, so basically here the audio of tensor we are receiving is actually for mix sound of the drums, bass, others, etc. Okay, so this is basically how we convert into data set here. Okay, we pass the audio part and make the data set here. Okay, and we'll be printing it to see if it works or not, and then finally our whole pipeline or data set is done. Now we'll go into data loader part. Okay, so it is the same data loader we talked about a little bit earlier. Okay, so how we'll do it? We'll do it by passing the data set by first importing from tos.utils.data, import data loader here, and then we initialize loader with our data loader, which will be taking the data set. Then here the batch size should be equals to 32 for our kaggle, and shuffle we could make it to true. Okay, if you will run this, our data loader part will also be done here. Okay, so since here our batch size is equals to 4 for our data loader, in the code the data set will be divided into 4 parts, and each batch size will have 250 songs. Okay, so here the batch size is 32 for our kaggle notebook. Then what we could do is that I could show you the audio and labels for our data set here. Okay, for our data loader we will be printing the audio and labels here, and we will be breaking it. Okay, so let the notebook run. Okay, and also for our GPU. Okay, so for this bootcamp project we'll be using GPU. Okay, so if you'll go to session output, you could see here GPU P100. Okay, and this one will be using for our bootcamp project. Okay, so we could load it by using device equals to tos dot device, where we supply CUDA if tos dot CUDA dot is slash available. Okay, if not, we'll be using CPU only. Okay, so we'll be then printing the device. Now if you will be running it, you will see here the device is using CUDA. Okay, for our fast development. Okay, so we will be training on GPU only for our this bootcamp here. Okay, and here in on data loader you could see here the audio and the label part here. Okay, so you could I forget to break here. So if we'll run it again, you could see here that the audio labels are then send it to CUDA device here. Okay, and this will learn in our next video. Okay, so I will be making a training loop and will be sending the data loader to CUDA. Okay, for our fast processing. So we reach to the end of the video, and in this video we learn about the audio data set, about the data loader, and how we use GPU inside our kaggle. In our next video we will be learning how to make a basic CNN model, how to attach WAN-DB, and how to train a model here. Okay, so our this code is run, and you will see here that the device using is CUDA. Okay, so in our next video we will be sending everything to our CUDA for fast processing. Okay, and we will be training by this only. So that's all for today. In our next video we will be doing this, and it will be an important lecture for our bootcamp here. So see you in my next video, and thank you and bye bye.